Alright, so for number 18, again, because it has an imaginary 0, we have to add its conjugate pair. So this would be x minus 3 plus 4i. Okay, so this one and this one are conjugate. These two are conjugate pairs. So now I'm going to simplify. X plus 7. Distribute the negatives in the other one, so x and the other two, x minus 3 plus 4i, and then x minus 3 minus 4i. So I'm going to do a 3 by 3, and so that's x minus 3 4i, x minus 3 minus 4i. So x squared minus 3x minus 4ix, and then negative 3x, 9, 12i. The last row is 4ix, negative 12i, and minus 16i squared. So negative 4ix and positive 4ix is gone. 12i minus 12i is gone. And this here is positive 16 because I squared is negative 1. So this is positive 16, which I'm going to add to the 9. Okay? So this is x plus 7. X squared minus 3 and negative 3 is negative 6x. And 9 and 16 is 25. Okay, so now I'm going to do another x and 7. X squared minus 6x, 25. So then that's x cubed, negative 6x squared, 25x, 7x squared, negative 42x, and then this is going to be 175. Okay, so f of x is x cubed. So 7x squared minus 6x squared is x squared. 25x minus 42x is going to be minus, is it 17x? And then plus 175. There's the answer. Alright, so number 19 is factoring completely. So this, you should recognize this as a sum of two cubes. And so the cube root of x cubed is x. Cube root of 125y cubed is 5y. And that's a binomial. The trinomial, you square the first one, you change the sign, it's the opposite sign, and then you multiply the x with the 5y, that gives you 5xy, and then it's always positive there, and then you square the last number, so that's 25, or the last term. And that would be the factored form of number 19. Alright, number 20 is the difference of two squares. So this one is 4 plus x squared and 4 minus x squared. Okay, this is the difference of two squares. This is not, but you could use imagine, because notice in instructions it says include irrational and complex factors. So this one could be, this one is 2i plus x and 2i minus x. And then the next one would be 2 plus x and 2 minus x. Okay, so quick correction on this. It should be negative 2i plus x, and then this is positive right here. Because when you distribute these two, you should get this back. Okay, and so it might be easier if you write it x squared plus 4, or keeping it like this is fine. But this is the factored form of 16 minus x to the 4th. So right here. Okay, 21 is another special type of trinomial. It's a perfect square trinomial, and how do we know that? because the square root of 16x squared is 4x, the square root of 25y squared is 5y. When you multiply 4 times 5 and you double, you get this, right? So then you know that this is how you factor this type of trinomial. That's it. Now 22 is the sum of two squares, and in real numbers you cannot factor. If we were just talking about real numbers, we would say this is unfactorable, or it's prime, or it's irreducible, whichever of those three that you want to say. But in complex numbers with imaginaries, we could factor it further. So the square root of t to the fourth is t squared. The square root of 16u squared is 4u squared. So I'm going to put 4u squared, u squared. But because it's a sum of two squares, I have to include the I. The I is the one that's going to help us factor it like this. For u squared I, like that. Alright, so number 23 does not factor with the x factor or with the box method. Either way, it does not factor that way. So if we're dealing with the just rational numbers or integers, it would not factor. Okay, but in real numbers, we could factor it if we're thinking of it in terms of real numbers. If we find the zero, what makes this polynomial 0, then we could factor it with x minus, like the ones above, the ones we did earlier. So let's go ahead and use the quadratic formula to find the zeros of this polynomial. So it's going to be x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So in this case a is 1, so 2 times 1. So this is negative 18 plus or minus, so square root of 18 squared is 324 minus 36 all over 2. And so that gives you negative 18 plus or minus 288, square root of 288 over 2. And 288 is, let's see, 936. It's divisible by 72, I believe. So let me just check real quick. Okay, so it's 144, right? 144 divided by 2. So 144, times 2 is 288. So 144, the square root of 144 is 12. So it's going to be negative 18 plus or minus 12 radical 2, because the 2 stays inside, over 2. Now, 2 is divisible, is a factor of 18, 12, and 2. So it's a factor of, when you reduce everything by 2, you get negative 9 plus or minus 6 radical 2. So these are the zeros of this polynomial right here. So to factor it, you would write x minus negative 9 plus 6 radical 2, and then x minus negative 9 minus 6 radical 2. And then you could just get rid of the parentheses inside and write x plus 9 minus 6 radical 2 and x plus 9 plus 6 radical 2. So this is a factored form with irrational numbers of x squared plus 18x plus 9. Okay, so here's another sum of two cubes. So the cube root of n to the 6th is n squared, and the cube root of 125 is 5. So you get this, and then this would be n to the 4th change the sign, 5n squared, and always positive, 5 times 5, 25. So that would be the factored form. Now, if you want to factor, they may ask you to factor it further, to factor, let me see, this one, you could factor this one further. This would be n plus square root of 5i times n minus square root of 5i. And then the next one, so the trinomial, we could just write it like that. So 25 factors by grouping, so you just put them in a 2 by 2 grid in standard form, x cubed 7x squared minus 81x minus 567. Greatest common factor in the first row is x squared. X times x squared is x cubed. 7 times x squared is 7x squared. And negative 81 times x is negative 81x. And then 7 times negative 81 gives you negative 567, so that one's right. So then you write x plus 7 times x squared minus 81. But this one could factor further because it's a difference of two squares. So x plus 9, x minus 9. Alright, so 26 has a common factor of 3z, so that's 9x squared plus 12x plus 4. And then this one is a perfect square trinomial. It's, let's bring down the 3z. 3x, the square root of 9x squared. 2 is the square root of 4. And then you do 3 times 2, that's 6. Double it, it's 12, so it works like this. Now, this looks like, in rational numbers, we would look to see if this was a cube number, and it's not. But with irrational numbers, we can factor it a little bit more. So, cube root of x to the third is x. Cube root of x of 65 is cube root of 65, like that. So that's the first, that's the binomial. For the trinomial, square the first term, change the sign, multiply cube root of 65 times x, and then you square, always positive, remember, you square that number, like that. So that would be a factored form of x cubed plus 65. Alright, so 28 is asking if it's possible to use a rational root theorem and synthetic division to factor the polynomial. Remember, the rational root theorem tells you the possible list of possible rational zeros in a polynomial. So for this one, it would only be, p plus or minus 1 plus or minus 2, and over here it'd be the q's plus or minus 1, 2, 3, and 6. Okay, so the p over q list is plus or minus 1, plus or minus 1/2. I'm taking the 1 here and putting it over each one of these 4. And then I'm going to do the same thing with the 2. So 1/2, 1/3, 1/6, and then 2 over 1 is 2. 2 over 2 is already on the list, which is 1. And then 2 over 3. 2 over 6 is 1/3, so it's already on the list, so I don't need that here, that comma. So this is the list of list of possible rational zeros for this polynomial. And notice this one right here, radical 6. No matter what when you multiply two rational numbers, you're not going to get an irrational number to cancel out. It's just not going to, it doesn't happen, right? It's not possible. So for that reason, you cannot use this theorem, this list here, to get the zeros for this polynomial, or to get a zero for this polynomial, because of this irrational coefficient right here. Okay.